Hey everyone and welcome! So today we are going to be teaching our very single-minded Arduino how to multitask. Now, of course, there are tons of different ways that you can do this, but today in particular, we're going to be looking at interrupts and two very simple ways to incorporate these interrupts. So if you have questions, I encourage you guys to join the community where you can watch all of these lessons live, ask your questions on the spot, and also, of course, afterwards, because the community is open 24/7. What is an interrupt, right? First of all, it's super rude, right? So your Arduino is executing its code line by line, and then it's a way to interrupt it in the middle of what it's doing and say, hey, can you do this thing over here? Just like take care of this real quick, and then you can get back to what you're doing and continue reading the code. It's great for reading sensors at a very timed interval, or when you have a button press or any type of internal or external signal that you want to respond to. So you can see that I have two LEDs. And the objective here is to have that red LED flashing at some rate. Whatever, we'll pick it. And then the blue LED, when I press that button, well, that blue LED better turn on. Better turn on. All right, so this is kind of like the challenge that we're going to try and solve with two different kinds of interrupts. There are hardware interrupts and software interrupts. Now, hardware interrupts rely on an external signal. So like a button press, a sensor reading or something that triggers our interrupt. And then there are software interrupts, and these are internal to the Arduino using its timers. So we're going to look at two examples, and we're going to look at very simple examples. So if you're just getting started out with Arduino, this is really great to add some multitasking functionality. And then, of course, there are more advanced techniques that we're going to look at in future streams. All right, so we have a blankety-blank sketch, and let's get started. So how would we do this? Well, first I'm going to declare my pins as variables. So I'm going to call it red LED, and red LED was hooked up to pin 12, I believe. And then we have our blue LED, and blue is just not spelling itself because it's like, yeah, it's already trying to sabotage my attempt here in proving that, maybe we can get this to work without interrupts, And then what else do we need? We need probably, the button. We can't forget the button. So the button pin. And that is on pin 4 because I just moved it. All right, I think that's kind of it. And of course, we're going to need a button state, but I think I'm going to declare that locally. So now we have our most prestigious setup where we'll set up our pin modes. So pin mode for the red LED is going to be output. And then pin mode for our blue LED. Now, if any of you guys have ever tried this, like trying to get the Arduino to multitask and have successfully done this without any interrupts or stuff, I would like to hear. And then pin mode for our button pin, well, we're using the internal pull-up resistor. So we're going to go input, pull-up. All right. And I think that's it for what we need. I'm just going to shrinkify the space right here and get into the loop. All right, so how are we going to handle this? Because I want it to really detect my button press, I'm going to have it read that button right off the bat. First line of code, like read my button. All right, so the button state. So I'm declaring a variable right in this function, a local variable, and I'm calling it button state. And how are we going to get the state of the button? Well, we're going to digital read the button pin. All right, sounds good. Now, if that button pin, if the button state, I guess, the state of the pin is equal to low, and low because we're using the internal pull-up means the button has been pressed, what's going to happen? Oh. Well, we're not finishing our thing right there. We're continuing. What's going to happen? Well, we want to turn that blue LED on. So we're going to turn it high. Okay, sounds good to me. Now, let's say that the button is not pressed. So if the button state, is equal to high, what happens? Well, we want to turn that blue LED off. I almost went off. No, we want to turn it low, which means off. We are sending 0 volts to it. All right, so I think we have some conditional statements there. So we've handled the button pressing right off the bat. So then we want to arrange this red blinky type of situation here. So let's do the red LED, or digital, right? The red LED high. And what rate do we want? Let's do like maybe a 250 milliseconds, kind of a fast blink. And then we're going to digital right the red LED low. Oh. And we're going to delay for also 250. So we get a nice even blink, not like a syncopated blink, although that is cool for, different animations and things. So this kind of looks right to me. So let's upload now this code here and see what happens. And it's asking to save. I care not for saving. Famous last words, right? Okay, so far so good. Look, that red LED is indeed blinking. Now, will that blue LED turn on when I push the button? Let's go look. Okay. Uh-oh. Okay, it turned on. Yeah, it's not real responsive. Like I was hoping that by putting our button read code right up front, we pretty much would be problem free. But as you can see, those delays when we get later into the sketch prevents the button from reading. And because we have fast delays, it's catching more button presses. If we were to make those delays even longer, like say a second each, well, those are whole second blocks that we're kind of stuck, where we can't really do anything. So yeah, not as responsive as I'd like it to be. So let's see if we can fix this. And the first type of interrupt we're going to try and use is the hardware interrupt. Hardware interrupts work on very specific pins of different Arduino boards. For the Arduino Uno, the hardware interrupt pins are pins 2 and 3. So whatever you want to interrupt, like the button is our interruptor, whatever is the interruptor needs to be plugged into one of those pins. And you can see that pin 2 is also known as interrupt vector 0. And pin 3 is interrupt vector 1. Now we're going to need to know vector 0 and vector 1 for our code. So we're going to kind of like keep that in mind. All right, so I am moving the button from pin 4 to pin 2. Now, it's good practice, unlike you saw me do, to always unplug your Arduino when you're making changes in your electrical connection. That just kind of like protects all your components. And every time I approach the Arduino, the components are like, oh, she's coming again. We're going to die. We're going to die. So yes, it's good practice to actually unplug your Arduino before making changes. Even the simplest changes I know seems kind of lame, but you forget. And then when you're working with other devices that are more sensitive, then yeah. They can get quite unhappy. All right, so how does one implement a hardware interrupt? Number 1, plug your interruptor into the correct pin. 2 or 3, you can also look at your board's data sheet and determine how many they have. Like the Arduino Uno has 2, other boards have more. So you might have more options in case you want many interrupters. Now you can have more than one interrupter, but they can only run one at a time. You can't have like multiple interrupting. It becomes far too rude. Your sketch becomes just way rude. Right now we're just kind of like casually rude, interrupting the Arduino from doing what it was doing. All right, so that's step 1. Step 2 is we need to create an interrupt service routine. And so this is a function that contains all the code of what we want to happen once the interruption occurs. So in our case, what we want to happen is for that blue LED to come on. So that would be our interrupt function. And so you're familiar with void setup, void loop. And so now we're going to create void, call it whatever we want, and then put the code in there that we want to use, that we want to happen. And then third is once that function happens, you have it in your code, you want to attach that function to the action, like the actual button press. Here is the attach function that we're going to use in the setup section. Once we've written our ISR or interrupt service routine function, this is how we attach it to the actual action. So you can see the function is rather easy. It does take a couple parameters that are somewhat self-explanatory, like attach interrupt. That kind of describes itself. So the first parameter it takes is the interrupt vector, not the pin. We connected it to pin 2, but pin 2 is interrupt vector 0. So you would put a 0 where that is. And then your ISR, which is your interrupt service routine name, whatever you name it. And we're going to name it something, and that'll go in there. And then the mode. And then you see for the mode, there are 4 options, all in caps. It's got to be caps for it to work, just like high or low with your digital writes. So it has rising. So when an input goes low to high, that's when it triggers it. Falling when it goes high to low. Low when it just stays low, and then change whenever the input changes. So for a button, change is kind of good, because it's either low, high, and it can kind of track those changes. So I think we're going to use change. Now, one of the things you're going to see a lot when people use hardware interrupts is this interrupt vector situation will look a little bit different, because wouldn't it be so much easier if we could just put a pin in there? Because then you can create a variable for your pin. And if you change boards, you just change it in that variable. It's so much better. So is there a way to do that? And yes. And so there's another function called the digital to pin interrupt. And you see that I have inserted it where our vector information was. So it's still the attach interrupt, but instead of putting that 0 where you have to look up the vector, you can just put your digital to pin interrupt function, and in between the parentheses where it says pin, you put a pin number and it returns that number in the Arduino. So you don't have to worry about tracking that. Also makes it much easier to swap boards for your project in case your project grows and you need even more pins. And then the rest of is the same. You have your interrupt service routine and your mode. So those are the advantages of, instead of putting your vector number in there, is to use the digital pin to interrupt function within a function, basically. All right. So how do we use this? Oh, we have to remember that the button pin is now pin 2. So that's important. So our pin modes are pretty much the same for the setup. And remember, we have to add our service interrupt routine. We have to attach it in the setup, and we need a name for it. We haven't created it. So how are we going to name it? Now, when you create additional functions other than the void setup or the void loop, you'll see it's like about 50-50. Some people kind of put them at the top, all of their functions that then get called in the main loop, or they put it at the very bottom. The choice is yours. Because we're going in order, I guess I'll put it right here at the top. So we're going to start with void, and you can already see it's all happy. It's like, ooh, we're going to create a new function. So I'm going to call it button interrupt. I know, real creative, right? Button interrupt. And you're going to create it just like your void setup and your void loop function with the double parentheses and then an open curly bracket. So in this code, what do we want to happen if the button is pushed, if it is pushed? So we want to take that button state and digital read the button pin. Basically, kind of like what we did before. We can probably copy paste a lot of this. And one thing I'm noticing is that button state, it's declared kind of like down here. And we'll get to that. I think I'm going to change the way this is done, because there's something really important about hardware interrupts where you want to make sure that your variables update within your ISR routine. So probably we can copy and paste a lot of this code right here and move this statements here, the checking of the button. I'm going to go ahead and cut, and I'm going to paste it here. All right, and I'm just going to fix some of this formatting a little bit. And so if to get the button state, we're going to digital read the button pin. And if it's been pressed, turn the blue light on. If it's not been pressed, turn it off. So that's going to be our interrupt service routine, our ISR. So that's already written, and that looks good there. Now, which means I don't need this button situation here. Now, one thing that I'm going to go back to up here in setting up our variables, anytime you're using an interrupt service routine that uses a variable inside, like button state, that is constantly changing, you want to make sure you declare them in a very special way. And that is using the word volatile. So you want to go volatile, int. And our volatile int is the button state. And I'm not going to really, give it a variable. So why are we using the word volatile? And this prevents the Arduino compiler from optimizing it and putting it in the storage register, like with all your other variables. It actually puts it in SRAM so it can be updated. So for instance, say that this is a variable that changes all the time, like sensor readings, button pushes. By the time you interrupt, that variable could have changed. If it appears elsewhere in your loop and that variable could change, well, your interrupt service routine could be running on the old value of the variable. So it's important to use the word volatile, the keyword volatile, anytime you're using hardware interrupts with a variable inside. All right. And to remember too, in your interrupt service routine, you don't want to use other things that also use other forms of interrupts, like delays are a no-no, millis, that sort of thing. You want to stay away from using those. And so if you need to use an interrupt that has a light going on and off, well, normally we do that with delays, so how would you do that? And we're going to get to that in a later example. But for now, all we're doing is checking button states, which is not requiring any type of delays. All right, so we have our ISR written. Let's attach it. So to attach it, it's attach interrupt, easy to remember. And we are going to put in, you can do vector 0 if you want, but I'm going to put in that function. I'm going to put it in here so we can use pins. So digital pin to interrupt. So what's the digital pin that we want to interrupt? And that is our button pin. Or you can put a pin number, but it's good practice to use our variables. And what's the name of our ISR? Well, up there, I called it void button interrupt. So it's button interrupt. And you want to use the same capitalization as you did before. And then after that, we have those 4 options: rising, falling, change. And because this is a button that's like on, off, because I'm going to press it a lot, I'm going to use change. So that should be good. And then our void loop honestly doesn't really change because we want that red LED to turn on, off, on, off. We're going to leave it at the 250. So anytime we push this button, it's going to say, heck, hold up, hold your horses right here. We're going to quickly carry this out right there and proceed to this. And it happens so fast that any type of delay is almost unnoticeable. So let's see how this works. And I'm going to go ahead and upload this situation right here. Uh-oh, it's angry about something. All right. Oh, is equal to high. And digital right is spelled wrong. There we go. Hopefully that's it. Yes. See, we all sent good vibes. All right. So now I'm going to press it and I'm getting my stance on. I told you I was going to press it a lot. I'm going to press it a ton. Guys, it is super responsive. So our hardware interrupt totally worked. Crushed it. So I will say that hardware interrupts are probably one of the more popular ones that I use. It doesn't require anything extra. As you guys saw, it's one line of code in your setup function, and then you write your function and put whatever you want in there, except delays, millis, and anything that uses interrupt. And that includes printing to the serial monitor. Yeah, so you definitely don't want to use those in your ISRs. So software interrupts, unlike the hardware interrupts, depend on internal timing, so it's not listening for anything externally. And so now we get into Arduino timers. Now, the subject of Arduino timers can get very complex, but there are easy ways to implement it. So we are going to look at one such beginner-friendly way to implement a timer. Now, this is perfect for things that you need to happen at a certain time, which is a little bit different than our button press. Our button press is just like, whenever you press me, whenever you press me. Your software timers are great for turning lights on and off, at a certain frequency or, interval. Checking for sensor readings at a certain interval. So it just keeps doing those checks and the rest of the program can run uninterrupted. Not interrupted, uninterrupted. All right, so how do we implement a software interrupt? Now, software interrupt depends on 3 timers. Your Arduino Uno has 3 timers. Timer 0, timer 0, timer 1, timer 2, and that's it. 0, 1, and 2. There's 3 timers. I was wanting to go to timer 3. So timer 0 is very important because that also handles your delays, your millis. So one would assume that's probably not a good idea to use timer 0. So that leaves timer 1 or 2 available. And I'm going to go with timer 1. For this lesson, the easiest way to kind of manipulate this timer and make it easier for us is to use a library. There's a great library called TimerOne. Yeah, that's why we're using the TimerOne of all the timers. So let's install this library first. To install this library, I just go to the Arduino playground section of the site, go to this first one right here, and it is a Google code situation, and I just go to the first one. So go ahead and download that zip file, or if you're watching this at a later date, download the most current version. Once you download an external library, like a zip file like that, then you can go into Sketch, include library, and then add a zip library. This is going to open up your browser. You select the zip library and it'll install it. Now, sometimes I find certain libraries, you have to restart Arduino. You got to shut down and restart, and then the library appears and it functions. This one, I didn't have to shut down. It just worked right out of the box, so that's good. So of course, with libraries in our code view here, we have to attach it. So let's attach our library, or include it, I should say. And that's with the pound include, and let's include our timer 1. And I think it is a number 1. Oh no, it's not. It is actually spelled out. It's a spelled out 1. All right, so we've included our library, and let's see what we have to do here. Red LED. And you know what? We are going to change up this circuit, because instead what we're going to do is forget the button. I'll even unhook the button. We're just going to deal with these 2 LEDs because, again, this is about timing. So we're going to keep the red LED blinking at that 250. But then the blue LED, why don't we blink it like once every second? So we're just going to blink that blue LED once every second. And like the hardware interrupt, this particular library uses 2 special pins on the Arduino Uno, and that is pin 9 and pin 10. And I believe our blue LED is indeed connected to pin 11, so I'm going to have to move it. And I'm going to put it on 10. So I'm already going to change it in the code here. I'm going to remove the button. And the mouse is like, well, I'm moving all your code all over the place. So let's do that. I'm going to go and change the blue pin to pin 10. So this button is getting unhooked. It kind of matters not. It's doing nothing. And heck, I'll even unhook the ground just to really put it in the corner. It's in the corner now. So our blue LED, in order for it to work with this library, it needs to go into 9 or 10. I'm putting it in 10. And again, I did the no-no. This thing is still plugged in. Should unplug it, do your things, plug it back in. We no longer need this volatile state situation going on here. All right, so here we do need an ISR still. we do need a block of code where we can say, hey, we want this to happen if the interrupt is triggered. So let's see. Well, we don't have a button interrupt. So what's this routine? I'm going to call it blue blink. Not real creative, but I use my creativity elsewhere. So it's like it's gone for tonight. It's gone. So no cool variable names. All right. We don't have any button situations going on. So what do we want to happen in this blue blink? Well, we want to digital write the blue. Oh, wait a minute. Normally, the way I would do this is digital write it high, delay for a minute, not a minute, a second. Then digital write low and delay it for a second. But remember, we can't use delays in this thing. So, or millis. So we're going to have to get creative. So here's a little trick. There's two ways I've done this. One way, which we've seen in previous Arduino courses, is to use if statements and assign a state to the LED and use a string. Is it on? Is it off? And have that if statement check repeatedly if it's on, if it's off, and then have it do the opposite. That requires no delays. But here's a fun little one-line trick that I wanted to show you guys. So one of the ways you can do this is digital write the blue LED. And what are we going to digital write? High or low? Well, why not write it by the digital read of the blue LED? All right, let me explain myself. If you guys have never seen this before. So we're going to digital write the blue LED because we want to be able to turn it on and off. And this exclamation point is the word not. So not this thing right here. So in essence, what we're doing is we're taking a digital read of the blue LED. Is it high or is it low? So say it's high and we need to turn it low. So it's going to digital write the blue LED not high. So that leaves low, right? Or say that it is low and we need to turn it on. So it's going to digital read the blue LED and say, oh, it's low. We need to turn it on. So write that blue LED not low. That means you got to write it high because we're not writing it low, not low. All right. You guys get the idea. So this little operator here is a very, clever little guy in order to kind of flip-flop. Anytime you need to flip-flop, this is kind of an interesting way to do it without using delays. Or you can do the if statements. I think both are just fine. The if statements are more lines of code, so some frown upon that, but you guys know my philosophy. If it's 1,000 lines to do something that takes 5 lines to do, if it works, it's good code. It's good code because it works, right? All right, so we have all that. So this is our void blue blink. All right, so we're going to remember what we called it. And here we're getting into our void setup. And we have our red LED, our blue LED as outputs. We no longer have a button, so that can go away. Oh, bye-bye. And we don't need this attached because this has to do with hardware interrupts and not software interrupts. So we're going to use 2 functions that come from the library, and you can read the library documentation. So TimerOne, we need to initialize it. So we're going to initialize it and then put these parentheses here. Now, what do we put in the parentheses? We want to put the interval at which we want this to happen in microseconds. So 1 second is 1,000,000 microseconds. So help me write this out, guys. It's 6 zeros. 1, 2, 3, 4, 5, 6. All right. No commas. So you are going to have to basically convert your timing into microseconds. All right. So theoretically, our blue blink is going to run every second. All right, the next thing that we have to put in here, and again with TimerOne, is similarly to the way we did the hardware interrupt, we have to attach it. So we're going to attach this interrupt, and we are going to attach it to blue blink. So you can see that this requires a lot less parameters, super easy. Now you can manually set these timers, slow down the timer using altering the chipsets, using prescalers. That allows you to get a lot more fine control of the timer than this method. But if you just want something to happen at a regular interval, this library makes everything super, super easy. All right. So I think that's what we have. And then the loop kind of stays the same. We really haven't touched the loop. So the loop is just going to keep going. It's going to keep turning on and off that red LED. And then the timer is going to interrupt that sequence every second and flip-flop the blue LED on or off via our one line of code. And let's upload this. Oh, it's angry about something. Oh, look at what I did. So we have a parentheses here and this parentheses, but this parentheses belong to this guy. So we need an extra parentheses here. I've been stingy with my parentheses, so Arduino doesn't appreciate that. Parentheses and curly brackets. It's like, don't be stingy with that stuff. All right. Guys, look at that. So we have our red LED blinking at that rate of 250 milliseconds. And you can see that there's no interruption, although technically there is an interruption because that's how all this is working. But it's responsive, I guess, is what I'm trying to say. And so this is kind of cool for applications where especially you are taking sensor readings, because imagine making a prop or a robot that needs to respond to environmental cues. Putting those responses and checking of sensors and things like that in a interrupt service routine is great because it doesn't interrupt what's going on with the rest of the code, and it's not going to miss any one of those cues. It's also useful for animations because you can have different animations going on at the same time. So there are a lot of ways to get Arduino to multitask, and using these interrupts is just one of those ways. There's also Millis, controlling timers at a more advanced level, but I wanted to gear this towards beginners, where if you're just getting started with your Arduinos, Arduino projects, you probably already run into this, where you're trying to do two things at once and the timing isn't just quite right. It's missing buttons, presses, it's not sensing something on time. And these are two quick fixes to help you handle your Arduino multitasking. These are shot live. You can ask questions in real time. I talk to you in real time. If you are watching this after the fact and you are a community member, we'll post up your questions. The community is open 24/7 and I'm on there every single day to help you guys out. Our members are awesome in helping you out. And the goal is to make us better builders, fabricators with our creative electronics projects, our animatronics and robotics projects. So guys, check you out later. I will include this code on my website. The link is going to be in the description. So kind of like scan it down and there'll be additional explanations. All right, guys, see ya. Because, somebody is just like, I'm done with this. I'm done with interrupts. And now she, our dog Ripley, is interrupting me. And if you hear the barking, it is like multiple interrupts, which I said is rude. One interrupt, not multiple interrupts. It's rude. See you guys.